Hello, everyone, and welcome to this explainer. Today, we're tackling what is honestly the most common and probably the most devastating security mistake developers make: secrets management. A single API key accidentally committed to a repository can literally hand an attacker the keys to your entire cloud infrastructure. So our goal today is to fix this completely. We're going to set up some ironclad secure coding principles to protect your apps from local dev all the way through to production. To understand what we're up against, the sheer scale of the problem is just staggering: 10 million. According to GitHub State of the Octoverse, there were over 10 million new secret exposures in public repos in 2023 alone. Attackers are actively scanning public repositories in real time. That means a secret you accidentally push can be compromised in literal seconds. It's not some rare fluke. It's a massive, active vulnerability happening every single day. And the real-world consequences? They're absolutely catastrophic. Take the 2016 Uber breach. Attackers found AWS credentials hard-coded right in a private GitHub repo used by their engineers. That gave them access to an S3 bucket with personal data on 57 million users and drivers. Or look at Capital One in 2019. A misconfigured web app firewall exposed AWS credentials, which cascaded into the theft of over 100 million customer records. Seriously, one leaked secret can bring down a whole enterprise. Okay, let's dive into this. Here is our game plan for today. We'll start with the secret exposure problem, then hit the golden rules. Next, we'll look at tooling and environments, how to actually write secure code. And finally, we'll wrap up with rotation and scanning. Let's kick things off with Section 1, the secret exposure problem. Before we can protect our secrets, we need to know exactly what they are. In app security, a secret is basically any piece of information that grants access and absolutely shouldn't be widely known. We're talking database passwords, API keys, TLS private keys, OAuth client secrets, the whole shebang. The crucial thing to remember here is that these are the keys to your kingdom. If attackers find these, they don't need to hunt for some complex zero-day vulnerability. They literally just log in. Which brings us to a pretty chilling reality. When you commit a secret to Git, it's there forever. Let that really sink in. You can delete the file, amend the commit, force push, doesn't matter. The secret still exists in the Git history. Attackers know this, and they are watching. Recovering from a leak doesn't just mean changing one line of code, it means finding everywhere that secret was used and rotating all of them at once.
All right, moving on to Section 2, the golden rules of secrets management.
Think of these as your 5 non-negotiable commandments. 1. Never hard-code secrets, not in config files, not in constants, not even in comments. 2. Never commit them to version control. If it's sensitive, keep it out of Git entirely. 3. Inject your secrets at runtime. Your app should fetch what it needs right as it starts up. 4. Automate rotation. This is absolutely huge. Manual rotation is rotation that simply doesn't happen. And 5. Apply least privilege. Give each service only the specific secrets it actually needs, not a master key to the whole system. So, how do we actually pull this off? That brings us to Section 3, tooling and environments. Luckily, the ecosystem for managing secrets is incredibly mature. If you need enterprise-grade control, HashiCorp Vault is kind of the gold standard. If you're fully built into a cloud provider, you've got native options like AWS Secrets Manager, Azure Key Vault, or Google Cloud Secret Manager. And if you want something super developer-friendly to get up and running fast, tools like Doppler and InPhysical are fantastic. But honestly, the specific tool you use doesn't matter nearly as much as the habit of using it. Pick one and use it everywhere, beyond your local laptop.
And speaking of laptops, we need to have a quick chat about .env files. They can be really confusing. The good news? They keep secrets out of your actual code locally. The bad news? They are dangerously easy to accidentally commit with a simple git add dot. And the ugly? .env files are just plain text sitting on your disk. No rotation, no audit trail, zero access control. So absolutely use them for local dev, but make sure they are in your Git ignore and never, ever use them in production.
Let's transition over to Section 4, writing secure code. So what does this actually look like in your code? Well, if you're writing Python, your workflow should go like this. Use python.dnv locally. In production, use an SDK like Bodo3 to pull from AWS Secrets Manager right at startup. Be sure to cache those secrets in memory. Don't keep fetching them on every single request, and obviously don't log them. And this next part is crucial. Use IAM roles or workload identity to authenticate.
If you're using long-lived access keys to get your secrets, you are literally just trading one secret management problem for another.
For all the Node.js developers tuning in, the principle is pretty similar. Load your secrets via SDKs during your app bootstrap before you even start listening for requests. Validate them right there and fail fast with a clear error if anything is missing. It's way safer to crash immediately than to fail mysteriously 20 minutes later. And a massive warning here for JavaScript devs. Be incredibly careful with process.env. If you accidentally spread it into a logging context, well, congratulations, you just logged all your secrets in plain text.
Now, for the Java ecosystem. The standard here is Spring Cloud config paired with a Vault backend. If you're running on Kubernetes, the external secrets operator is awesome for syncing secrets right into Kubernetes secret objects, but a huge red flag for those using traditional app servers. While JNDI can be used to inject secrets, it has been the root cause of some catastrophic vulnerabilities. I mean, we all remember Log4Shell. You have to sanitize and validate absolutely anything coming through JNDI. No exceptions. Finally, that brings us to Section 5, rotation and scanning. So even if your code is perfect, secrets get old and accidents happen. They need an expiration date. But if you just swap a database password while the app is live, everything crashes. The fix here is zero downtime rotation. It's basically a 4-step dance. First, you generate a new secret. Second, deploy it alongside the old one so they both work. Third, update your app to prefer the new secret and wait for all the instances to catch up. And fourth, safely revoke the old one. Keep in mind, both your app and your secrets manager have to support this flow. And to catch those inevitable human mistakes, you need active defense. Pre-commit hooks are literally your last line of defense before a secret gets permanently etched into Git. Tools like Git Secrets, TruffleHog, and Detect Secrets will actively scan your stage changes. Platforms like GitHub have native push protection now, and GitLab has secret detection built right in. Please listen to me on this. If one of these tools blocks your commit, do not just disable it to force your push through. Investigate it. It probably just saved your company from a headline-making disaster.
Let's wrap up this explainer with a quick question to test what we've covered today. Why is it not enough to just delete a hard-coded secret from a file and commit that deletion? Well, because Git is forever. That secret is still sitting right there in the commit history for anyone with access to find. Once it touches Git, consider it compromised. You have to completely revoke and rotate it across your whole infrastructure. You've really got to treat these things like the crown jewels they are, because a single leaked secret can completely bypass months of hard security work. So ask yourself, if an attacker cloned your repo right now, what keys to the kingdom would they find hiding in your history?